Tutorial for the Edexcel Further Pure 1 Maths course. This is the first video on matrices. This should be applicable to most other further maths modules, and if you need more help with your maths studies, GCSE or A-level, do see the YouTube channel or website. As we always do, let's start looking at the specification. Edexcel has a chapter, a section called section 4, and it says what students need to learn about matrix algebra. It's quite a heavy amount students need to learn. It's on 2 pages here. We're not going to do it with the second page for a couple of videos, so I'm not going to talk about that now. But what we're going to start off with, we're going to talk about what matrices are. And in this particular video, all we're going to get to, we're going to add and subtract matrices, and we're going to multiply a matrix by a scalar. Future videos, we're going to cover products of matrices, which is multiplying, and determinants and inverses, which is really how to divide matrices. Okay, let's start off by a little video clip for you.
At last. Welcome to you. As you no doubt have guessed, I am Morpheus.
It's an honor to meet you.
No, the honor is mine. Please, come, sit. I imagine that right now you're feeling a bit like Alice. Tumbling down the rabbit hole?
You could say that.
I can see it in your eyes. You have the look of a man who accepts what he sees because he is expecting to wake up. Ironically, this is not far from the truth. Do you believe in fate, Neil?
No,
Why not?
because I don't like the idea that I'm not in control of my life.
I know exactly what you mean. Let me tell you why you're here. You're here because you know something. What you know you can't explain, but you feel it. You felt it your entire life, that there's something wrong with the world. You don't know what it is, but it's there, like a splinter in your mind, driving you mad. It is this feeling that has brought you to me. Do you know what I'm talking about?
The Matrix.
Do you want to know what it is?
Now, I can't promise when I'm going to tell you about matrices for Further Pure 1 that it's going to help you be able to avoid bullets and bend down to the floor. But there are some similarities to the concept of the matrix in the film and matrices in mathematics. When Neo in the film finds out about matrices, all of a sudden, lots of things that were impossible in the past or difficult for him to do, he can now do. And also, matrices were around him before, but he didn't realize it. And similarly, when I show you the idea of matrices and we fully get our head around it, you will see that matrices will allow you to do things in maths that otherwise you would have found very difficult. And it describes mathematics that you've always been looking at, but puts it in a different picture. Okay, let's actually find out then what a matrix is in maths. The following 4 are examples of matrices. Now, just a point to note that the plural of matrix is matrices. So each of these 4 are matrices. So if I asked you to have a guess at what a definition of a matrix is, you might be able to do so. Think about it for a second. And a matrix turns out to be something very simple. All it is a rectangular grid or array of numbers. It's a collection of numbers in a rectangle or grid. Okay, next thing to state. We always denote matrices with capital letters and we make them bold. So when we're calling them things, we might say, for example, this is matrix A. and we make it bold and capital. This is matrix B. This is matrix C. And this might be, you know, it doesn't have to be ABC, it might be M sometimes we use, okay? So we always denote a matrix with a capital letter and we try and make it look bold. Okay, next thing to say, what are the things inside a matrix? What are those numbers called? Well, the numbers in the matrix are called its elements. And the elements that we're going to use will always be real numbers. Okay, will always be numbers on the number line. They won't be complex numbers in FP1, so they'll always be real numbers. And the last thing to say is that the dimension or order of a matrix tells us how many rows and columns it has, i.e. how big it is. Okay, so the word dimension or order of a matrix is describing how many rows and columns it has. And we say that a matrix with R rows, an R number of rows, say 3 rows, and C columns, say 4 columns, is an R by C matrix. We would call it a 3 by 4 matrix. Okay, now for example, in A, how many rows does it have? 1, 2, 3 rows. How many columns does it have? 1, 2, 3 columns. This would therefore be a 3 by 3 matrix. Matrix B, how many rows? 1, 2. How many columns? 1, 2, 3. R times C, it would be 2 times 3. Matrix C, 2 rows, 1 column, so it would be 2 by 1. And matrix M, 2 rows, 2 columns, it would be 2 by 2. Now, it helps me to remember RC. I use RC because I remember really confusing. The R of really and the C of confusing. It's really confusing because really you're counting down first and then across, and usually with everything in maths we've done before, you go across first and then up or down. So to count this matrix, how big it is, it's 1, 2, 3 down and 1, 2, 3 across. This one is 2 down and it's 3 across, so 2 by 3. And it helps me remember it. But R by C, rows first, then columns. That also helps you remember it. Okay, time for you to state the order of a few matrices. Here we go. The order of dimensions of these matrices. State them for each of A to F. Pause the video, have a go. I'll go through in 5 seconds. Okay, just going through this, 2 rows, 2 columns, 2 by 2. Remember, R times C. Okay, this one, 2 rows, 1 column, so 2 by 1. This one, 2 rows, 1, 2, 3 columns, 2 by 3. This one, 1 row, 1, 2, 3 columns, so it's a 1 by 3. This one, 1 row, 2 columns, so it's a 1 by 2. And this one, 1, 2, 3 rows, 1, 2, 3 columns, it's a 3 by 3. And it's as simple as that. Okay, next thing we need to look at. Special types of matrices, okay? So there is a few special types of matrix we need to know about. The first one is a matrix that has the same number of rows and columns. This one is a 2 by 2, remember? And this one would be a 3 by 3. Because of the way they look, they arrange themselves in a square, they're called square matrices. So a square matrix has the same number of rows and columns, for example, n by n, 2 by 2 and 3 by 3. Okay, next type of matrix is what's called a column matrix, okay? This one has n rows and 1 column. It only has 1 column. So this one was a 2 by 1, and this one is a 3 by 1. And that's called a column matrix because it looks like 1 column of numbers. And I'm sure you can guess what the last one is going to be. We've had a square, we've had a column matrix. The next one we must have a row matrix. It has 1 row and it has several columns. So this one here would be 1 by 2 and this one here would be a 1 by 3. In general, it's a 1 by n matrix. It's a column, it's a row of numbers. Okay, next little activity, tiny activity. Pause the video, have a go. For each of the following, state whether they are square, or a column matrix, or a row matrix, or neither. Off you go. Okay, clearly 2 by 2, so this is square. This is a 2 by 1, so it's a column matrix. This one is neither square nor row nor column, so it's neither. This one is clearly a row matrix. This one again is a row matrix, and the last one's 3 by 3, so it's a square matrix. Okay, right, now we've introduced the idea of a matrix. We've learnt how to write them. We know the numbers in them are called elements. We know how to describe the size of a matrix in terms of R times C, or its dimension. And we know about specific matrices, square, column, and row matrices. Okay, now we need to do some operations with matrices. The syllabus says that we need to be able to add and subtract matrices, multiply matrices by a scalar, and we also need to product of matrices, so multiply matrices, and do the following two things here, which are effectively divide matrices. Now in this video I'm just going to cover addition and subtraction and multiplication by a scalar. The rest, this will be in this video here. Multiplication will probably be in its own video, and division will be in its own video. Right, let's try and add and subtract some matrices. Here's a question for you before I tell you how to do it. A to E are a set of questions. Which of the following do you think it is possible to add and subtract to perform the question I've asked? And why do you think so? And what would the answer for each one that you can do be? Pause the video, have a think, and then I'll go through in a second. Okay, now, what I wanted you to see from this is that if you just guessed how to add or subtract matrices, hopefully you would have thought, I can do that one, I can do that one, I can do that one. Because all I have to do is add or subtract the corresponding elements with each other. And hopefully you might have thought to yourself, maybe I can't do that one or that one, because there is a 3 and -1 here, but there is a 1 and 2 in a column here. It doesn't seem that there are enough elements to compare to each other to add. Okay, so these three you could do because they are the same size or order, and this one you couldn't do because they have a different order. Now, how you might have guessed to do them, hopefully you might have thought, well, if I'm adding, maybe I just add the 1 and the 1 and I get 2, the 0 and the 3, I get 3, the -1 and the 0, I get -1, and the -1, add the -1, which would be -2. This one here, taken away, 1 take away 1 is 0, 0 take away 2 is -2. And this one here, this one here, 1 add 6 is 7, 0 add -7 is -7, 0 add 10 is 10, 0 add 0 is 0, 1 add 3 is 4, 0 add -1 is -1, 0 add 0 is 0, 0 add 5 is 5, and 1 add -7 is -6. Okay, and that would have been the answer for that one. So, let's try and generalize this. If you're adding and subtracting with matrices, you can only add or subtract matrices that have the same dimension. And to do that, you simply add corresponding elements. So if I was given a general rule, say, if I had a matrix A, B, C, D, and I was, let's say, adding the matrix E, F, G, H, okay, I would get the following. I would get A plus E in that for that element of the matrix. I would get B plus F, I would get C plus G, and I would get D plus H. Okay, and the same thing with subtraction. So here's an example. It's probably best, it's so easy, you pause the video, work it out, and check we get the same answers in 5 seconds. Okay, going through this one, 1 add -1 is 1. -1 add 4 is 3. 0 add 5 is 5. And 3 add 3 is 6. You should have got that. Next one, 1 take away 0 is 1. -3 take away 2 is -5. 4 take away 1 is 3. 2 take away 5 is -3. 1 take away 2 is -1. And 1 take away 3 is -2. You should have got that. Okay, I want to do another example. Just complicates things slightly, but again, it's very straightforward, so I'd encourage you to pause the video and try yourself before you watch me do it. Here's a question, here's a matrix, here are 3 matrices, and it tells you that A plus B always is C. So if I add A and B, I get C. Use this to find the values of A, B, X, and Y. Off you go. Pause the video, have a go. In 10 seconds, I'll go through. Okay, so going through these then. A plus B is equal to C. So let's just write down what we're told. 2, 3, 1, A. If I add that to B, negative 1, 2, and 4, I am told that I definitely get 3y, x, and 3. Okay, I'm told that with absolute fact. Okay, next, let's go and add this side. So this would give me, if I actually combined these and added them, 2 plus b, 3 plus negative 1, which is 2, 1 plus 2 is 3, and a plus 4. And that would still equal 3y, x, and 3. Now, for two matrices to be equal, each of their elements must be exactly the same. So what I can say from this, looking at this, clearly y must be the value 2, okay, for this to equal this. And also, looking at this and this, x must be equal to 3. It absolutely has to be equal to 3, okay? Now, next thing, what could I do next? Well, what I could do now is I could say, well, that must equal 3, so 2 plus b must equal 3, so b must be the number 1. And lastly, a plus 4 must equal 3, so a must be equal to negative 1. So have I found a, b, and c? Well, a is negative 1, b is 1, y is 2, x is 3. Very, very simple. Okay. Now, we've done everything on adding and subtracting matrices. Let's move on to the next idea. The next idea is multiplying matrices by a scalar. What I mean by that is, imagine I wrote down 2 lots of 2 minus 1, 0, 3. Okay? Imagine I wrote that down and I asked you what the answer is. Well, that actually means, just like in normal arithmetic with numbers, that means 2 lots of this matrix. So it means 2, negative 1, 0, 3 plus 2, negative 1, 0, 3, which is the answer 4, negative 2, 0, 6. Okay? Now, can you spot a quick way of doing that? Well, yes, I could have just multiplied each element by the 2 and I would have got that answer. Okay, so that's what multiplying by a scalar is. A scalar is not a matrix, it's a number. Multiplying a matrix by a number. So just explaining what this is, this means multiplying a matrix by a real number, in fact, for our course, by a real number. And in general, let's write down a rule. If I was multiplying a matrix A, B, C, and D by some number k, what would the answer be? Well, it would be simply KA, KB, KC, and KD. And that's our rule. Okay, given that I've just gone through that, maybe you'd like to pause the video and do example 3 on your own. It's very straightforward. So pause the video, in 5 seconds I'll go through. Right, A, well, I'm working out 2 lots of the matrix 1, 2, negative 1, 0, and clearly you just multiply all elements by 2, so 2, 4, negative 2, and 0, simple. And B, it works exactly the same. You multiply each element by a half, so you had 6, 0, negative 4. Multiply everything by a half, and you should get 3, 0, negative 2. As simple as that. Okay, I'm going to do one more example with multiplying by matrices by a scalar, a sort of a slightly more complicated problem. Again, all the ideas are simple. I encourage you to pause the video, try yourself, and then check you got the right answer. Okay, well, let's just write out this equation here. A plus 2 lots of B is equal to C. So you know that A, 0, 1 and 2, okay, plus 2 lots of the matrix 1, B, 0 and 3 must give you the answer of matrix C, which is 6, 6, 1 and C. Right, let's actually work this out here. That would be A, 0, 1, 2 plus, well, I can multiply each element by 2, so it would be 2, 2b, 0 and 6. And I know that must equal 6, 6, 1 and C. Now I should add the matrices on the left hand side, so I would get A plus 2 in this element, this top element, then I would get 2b here, then I would get 1 here, and I would get 2 plus 6, which is 8 here. And I know that must equal 6, 6, 1 and C. Now, for the matrices to be equal, each element has to be the same. So hopefully now I'll be able to work out the unknowns here. Well, the first thing to say is C is clearly 8. C is clearly 8 from that. 2b is equal to 6, so b must be equal to 3. And a plus 2 is equal to 6, so a must be 4. And just to check we've done it right, the 1 is equal to 1 here, and it's correct. And that's very simple. So in this video, we know what a matrix is. It's a row, or it's a grid or array of numbers. We know how to describe the size of a matrix, the dimension of the matrix. We know how to add matrices, and we know how to multiply matrices by a scalar. And that's all for this particular video. So just to tie everything up, I'd encourage you to read chapter 4, page 70 to 77, do the examples, and do exercise 4a and 4b, all of them. And then tune in for the next video where we do multiplying matrices. Thank you for watching.